Here we will be solving binary tree level order traversal. It's LeetCode 102. Let's first look at the description. Given a binary tree, return the level order traversal of its nodes values, i.e. from left to right, level by level. So we are giving this node, and the output is this array. So we have level 1, level 2 is this array, and the final level 3 array goes here. Okay, let's look at the solution. So we have this binary search tree or binary tree. In this example, we have 3 levels. So this is level 1, level 2, and level 3. And what we will be doing is just putting each level inside its own array. Right? And the result will be array of arrays. Okay. So to do breadth first search, so to do this, we will use queues, right? And just do breadth first search traversal, right? Okay. We will have few variables, so we need queue. We will have length of the current level. We also need current level array. The current node and result. Queue will be initialized with the first root node, so we have 3. Length of the queue is 1. Current level, it's initialized to empty array. Current node is null, and result, it's empty array. Okay. So what we'll be doing is just traversing each level and just putting each level to the results final array. Okay. So let's do it. So the current level, we just first pop or shift dequeue the current node and put it inside the current variable, it's 3. We then push the value of the current node to the current level, which is 3. Okay, we are done with current level, and we just push the current level to the results variable. Okay. Oh, no, it's wrong. Before we do that, we just ask ourselves, does the current node have any children? It does. So we just push its children to the queue, right? And in the next iteration, the length for the level 2 is 2. So the length of the queue is 2. We take this 9 node and put it inside current. We then push the value of 9 into current level. Does 9 have any children? It does not, so we don't push anything to the queue. We then take 20, put it inside current node. It's our current node. Then push the value of the current node to the current level, which is 20. Does 20 have any children? It does. We push those children to the queue, so we have left child is 15 and right child is 7. Okay, we're done with current level, and we push current level to the result. Okay, now we have the final level 3. The length of the queue is 2. Current level is initialized to empty array. we take the node from the queue, it's 15. We push the value from the current node to the current level, and we ask ourselves, does this current node have any children? It does not. We don't push anything to the queue. We're done with this node, so let's shift node and put it inside the current variable, so it's 7. We then push the value from the current node to the current level, and node 7 doesn't have any children, so we're done. We then push the current level to our results array. Okay, and we then just return our results array. Cool. Let's talk about time space complexity. So for time, it's O of n because we are visiting each node, and for space, we could say it's O of n, but maybe better would be to say O of m, meaning number of levels. Okay, so now I want you to just pause this video and try to code up the solution yourself. Okay, let's do it together. So first we need result array. We also need queue, which will be initialized to the root node. If our root is undefined or null, we just return empty array. Okay, so while queue has any nodes, we just initialize current level to the empty array. Array. Oops. So we need also the length of the current level of the queue with that, and we need for loop. Slash init for when. Okay, if I is equal to length, we know that we want to push current level to the results array. Okay. Else, let's see. So we need current variable, which is the first element from the queue. We will use JavaScript's shift function, which is not ideal because it's not the most performant, but yeah, that's because we're using array instead of queue, right? Okay, so we have a current node, and we need to push this current node's value to the current level, right? And if current node so child left child, if current node has left child, then we push this left child to the queue. And we do the same for the right child. we just return the result. Okay, let's see. If the root is null or undefined, we just return an empty array. We have a results variable. We have q, and while we have any nodes inside the queue, we just initialize length for the current level, initialize current level to empty array. We have then a for loop, right? If I is equals to length, we know that we need to push results to the so current level push to the results array. If not, we need to just take care of nodes from the current level. So we're shifting the first element from the array and put it inside the current variable. We're pushing the value for the current node to the current level, and then if there are any children for current level, we just push them to the queue. Yeah, I hope you understand this. Like, yeah, it's kind of mouthful, everything. Okay, so let's just run it through all the test cases, and they run. Yeah, like this coding challenge could be quite tough if you are not familiar with breadth first search. So if you are struggling to just understanding my solution and the drawings, just draw it yourself. Try that. Try to code up the solution yourself, and just maybe give it a day or two, or even 3. So like, okay. So I hope that helped, and till next time. Bye.